Import numpy as np. Import matplotlib.pyplot as plt. X equals np.linspace 010 Y equals np.xexp. PLT figure, fig size N5. PLT fill between X, Y, color Y, NP65, color 0.6. PLT plot X, Y, color C7039, line width 2. PLT title, energy dissipation over time. Font size 14, font weight bold. PLT X label, time energy level. PLT grid alpha 0.4. PLT tight layout, PLT show. This graph visualizes an exponential decay function, modeling how energy decreases over time. It effectively simulates processes such as energy dissipation, radioactive decay, or cooling. Function details. The function plotted is y equals e minus 0.4x. Y equals e minus 0.4x, which represents a rapid decay where energy levels drop off quickly at first, then taper gradually as time progresses. Visual features. The red shaded area under the curve, fill between, emphasizes the total energy lost over time. A crimson-colored line overlays the filled area to highlight the exact trajectory of the decay. Axes. X-axis labeled time, representing the progression over a period. Y-axis, labeled energy level, showing the diminishing values. A light grid adds clarity without distracting from the main curve. The figure is well balanced with tight layout to ensure elements are properly spaced. Usefulness. This type of graph is ideal for explaining physical systems that lose energy, like damped oscillators or electrical discharge, demonstrating the concept of exponential decay in math, physics, or engineering.